Hello and welcome back to the Isobel podcast. I'm marine biologist Nadia Frontier here with more conversations recorded during my time with the British Antarctic Survey. This episode features another very special conversation with a unique group of people working across two projects. One titled Drivers and Effects of Fluctuation in Sea Ice in the Antarctic, or known as DEFIANT, which is a much easier acronym to say, and kudos to whoever came up with that. The other is the European Space Agency, ESA, and together the team use a combination of cutting-edge resources like the infamous underwater vehicle Boaty McBoatface, research vessels such as the Sir David Attenborough, and the German ship, research vessel Polarstern. All this is to further our knowledge of changing sea ice conditions around Antarctica and the resultant global impact of climate change. Part of this project was based at Rothera, and for some of the team it was their first visit. I managed to snatch them at the end, along with my co-host and tower operator, Matt Hughes, and we coerced the team into the library where we recorded this interview. You'll hear a little bit more about their experience, but for now, I think I should let them all introduce themselves. Hello, the Defiant team. Thank you very much for joining us here on the Isobel podcast. Could one of you introduce your project?
This is two projects. This is Defiant for NERC, and that's aimed at studying changes in sea ice in the Southern Ocean and how they affect the wider climate system. And it's also CRYOVEX for the European Space Agency, which is their periodic ground campaigns to calibrate and validate satellite measurements from space.
Excellent. So we've got 6 of you here. So it's a really nice group interview. So if I go around the room and if you could all start with introducing yourself and the institute that you're affiliated with.
I'm Andy Shepherd. I currently work at Leeds University. I'll be shortly at Northumbria University, and I'm Principal Scientific Advisor to the CRYSAT mission.
I'm Inès Otosaka, and I work with Andy at the University of Leeds, and I'm a research fellow for the Centre for Observations and Modelling in Leeds, and I'm a land ice scientist.
I'm Sebastian Simonsen from the Danish Technical University. I do quite a lot of these airborne campaigns in relation to CRYOVEX.
That's you. I'm Isobel Lawrence. I work for the European Space Agency and I'm a sea ice remote sensing specialist.
I'm Gaëlle Veyssière. I am a postdoctoral researcher at the British Antarctic Survey, and I'm a snow and sea ice physicist.
Hi, I'm Carl Rumson. I work for British Antarctic Survey, where I'm head of Airborne Survey Technology.
So what are the main aims of the projects?
From the Defiant side of things, as Andy's already said, the aims are about better understanding variability in Antarctic sea ice. The specific aims of the Airborne campaign that we ran this week were to underfly satellite orbits with our suite of instrumentation, which we have on the aircraft, in order to get a better understanding of what the satellites are observing when they fly over the Antarctic sea ice.
So a way of kind of ground truthing the satellite data.
Exactly.
And how long have these kind of ground truthing calibrations been conducted for?
Within CRYOVEX or ESA campaigns, we have done it since 2003, pre-launch of CRYOSat 1. Then we had the launch of CRYOSat 2, and we have done it ever since, basically. So for the last 20 years almost.
Mostly in Greenland.
Mostly in Greenland, and that's also the opportunity here to actually try to see how's the sea ice looking in Antarctic.
Okay, and in Antarctica. So your aim, you've come here for 2 weeks?
Yes.
Yes,
2 weeks.
2 weeks.
And you're using one of the British Antarctic Survey's aircraft, the Dash 7. So how have you fitted the Dash 7 out with various instrumentations to achieve these aims?
Well, it all basically started actually in January when we received the requirements of all the various instruments. It's a wide range of instruments. Crisis radar system, which is a multi-band radar system, and then all the way through to radiometers on the roof and looking down, and LiDARs and multiple cameras looking at every window of the cabin basically to capture basically everything we can. And then during this sort of the year, we've been working with Voyager avionics in North Bay in Canada, and they've done all this sort of certification and modification of the aircraft in order to install the pressure box. the Dash 7 is a pressurised aircraft. So there's a lot of work gone on in terms of the aircraft engineer, and Voyager have been really supportive. And we test flew in July this year, packed up and then brought all the equipment here to refit here.
How long did the refit take from arriving to Antarctica?
It really helped during the summer to do a trial run. So trial run in the summer was over 2 weeks to sort all the engineering out. And then down here, we basically spent 4 days installing the equipment on the aircraft. 2 days initially prep, then 2 days install onto the aircraft.
That is an impressive turnaround. Were you quite pleased with that success? Did you think it would take longer given the amount of obstacles and hurdles there normally are down here?
I was pleased with that because 4 days is what I predicted. So.
Oh, perfect.
So it worked
Actually,
out.
planning worked out. And what about these transects? How do you define where you're going to fly?
It was basically solely dictated by the satellite orbits in terms of where we were aiming for in the Weddell Sea. So before we arrived, we had intended to fly in both the Weddell Sea on the eastern side of the peninsula and the Bellingshausen on the western side of the peninsula. But there's very little ice in the Bellingshausen this year, so we then pushed all the Weddell Sea flights as our priority. And there was one a day within the range of Rotherham Base, so that was our target for each day.
And how many transects did you conduct?
We flew 5 satellite orbits, one of which was a coincident where the 2 satellites that we're aiming to target, Cryosat and ISAT, both flew at the same time. That was our kind of prize aim, to underfly that one, and we did successfully. So.
And you guys were flying quite low, about 1,000 feet. Why was it important to fly that low?
Basically, one of our main instruments is the Airborne LiDAR system, and we want to have a SWAT range for the LiDAR, and we have the same SWAT range as we fly high. So basically 1,000 feet gives us 1,000 feet of scan of the surface. So that's a good compromise.
And what are you doing when the Dash is in flight?
We are mostly monitoring all the kind of data that are coming in. So I think it was kind of a journey to get used to understanding the whole process and to turning everything on and monitoring the data. But then once we're flying, we just check that everything's working, data's coming in, and if possible, trying to figure out if any issues are coming in.
Yeah, was it hard to stay awake during the night flights?
No, it was fine. I guess you just get used to it and you just pay attention to the data coming in. It's fine. And the view is really nice when you're in the plane by day.
Yeah, lucky. And also 24 hours of daylight, so constantly good. And you guys have had exceptionally good weather, which has allowed you to have such a successful campaign. So in addition to the aerial flying, there's also the ground team. So what does the ground team do?
So we try to complement all of the airborne data sets that they collect. So it's really important that we also go on the ground. So we went on land ice over Adelaide Island, so very short flight by Twin Otter, like about 15-minute flight, but beautiful views as well, with nice mountains and icebergs. And then we land there, so we went to different sites and we deployed some instrumentation to help the airborne survey. So we deployed 4 corner reflectors above the ground. So those are just triangular tripods, and which provides just very bright surface. So that is, they're really easy to spot in the airborne radar and laser data. So they're really helpful for doing the calibration of all of the data sets together. And we also did some ice scoring. So it's basically just drilling through the snow, fern and ice layers, because we're interested in using 2 different satellites together. So the Cryosat and ISAT 2 satellites. So one is a radar and the other one is a laser. And with those satellites, we can measure sea ice thickness and also land ice surface elevation. And in principle, they provide the exact same measurements, but actually because the principle is quite different from radar and laser. So we're really interested into looking more into the physical properties of the snow and fern and ice layers, and try to understand a little bit better the differences between the 2 satellites, and also between all of the data sets that are being collected by the airborne team. So it's quite a complementary ground survey as well. And so then we will try to assemble all of the data sets together from the ground, the airborne, and from the satellite.
To give a really good picture. And what does it involve actually taking the cores? How do you get those measurements?
A lot of hard work. First you have to
Yeah.
dig.
Yeah, first,
Lots of digging, and then
Do you enjoy digging?
I'm digging this afternoon actually on Scrub Out, so I'm looking forward to it.
Scrub Out.
Yeah. No, dig holes to put the tripods in, and lift the tripods up, and then drill lots and lots of boreholes, and that's the heavy lifting is then pulling the ice cores up from 7 meters below the surface, and that hurt my shoulder in the end, but it's all worth it for science.
And in total, we collected 52 meters of ice. So I think that was a really good campaign for us, because usually when we do those kind of campaigns also in Greenland with also Sebastian, but yeah, 7 meters I think is quite nice, because then we can drill through the previous melt layers from previous years, and then it's really helpful so that we can compare to the airborne data and also to a fan density model. So it was really important that we tried really hard this time and tried to drill quite deep. And thanks to Andy, we managed to.
It was a lot easier here because, believe it or not, it's a lot warmer here than it is in Greenland. So in Greenland, we're used to minus 40 around that, and that's pretty hard. You can stay out of the plane for an hour and then back in again. But here, it's t-shirt weather.
Yeah, and also we were with field guides and very friendly pilots as well, who were also giving us a hand. So it was very nice field work.
And you do some of the weighing in situ, and then you also bring some of these cores back and do analysis.
We do all of the work here at Rotherham. We bring the cores back from the field site on Fuchs Ice Piedmont, bring it back here, and then we do the stratigraphy on them. We count where the ice lenses are in every section of core, take some photographs, and then Inès is weighing segments of the core to get the density, the bulk density. And all of this will tell us something about the snow surface structure when we get back, and we'll compare that to the radar and laser measurements to understand a bit more about what's controlling the depth to which the different sensors penetrate into the surface.
What are the greatest challenges that you've encountered so far?
The timings was a big challenge, because when we had these potential flights in the Bellingshausen Sea, the timings were kind of less antisocial than they ended up becoming when we switched solely to the Weddell. So, as Gaëlle mentioned, we had some that were in the afternoon, but half of them were in very early morning. So that meant leaving base at midnight, 1 a.m. local time, flying out to the Weddell. So, yeah, there was shift work involved in that, not just for us, but also for the whole of the station. So we had an incredibly supportive group of people here who were willing to stay up all night and fly us around. So that was great. But yeah, that was one of the biggest challenges, I think.
How does this all fit into like the bigger picture? Because I remember you guys mentioning the other day that the Antarctic sea ice had been increasing up until recently and may be starting to decline now. How does all this work fit into all of that?
Yeah, so that's the kind of big mystery that this project is partly trying to solve. Antarctic sea ice is kind of one of the remaining data sets and climate variables that is still quite uncertain. So we have this record that only gives us the aerial coverage of the sea ice. And that's a really valuable record because it's 40 years long, so it can tell us a lot about what the sea ice has been doing, but it only gives us a 2-dimensional picture. And so a lot of the work we're doing here, what Inès discussed about the penetration depths, and that's all towards the aim of getting better thickness estimates, which can give us volume, mass. And that means that trends that we see in the sea ice cover, we can understand what that means in terms of how the mass of the sea ice is changing. And that's important for effects on sort of wider global effects like ocean circulation and ecosystems.
How are you going to all work up this data if you're going to leave Rotherham and then you're not going to be together, be all in different institutes?
Well, it's a collaborative project anyway. DEFIANT is in particular. So most of us are involved in the project either directly because we're based in the UK or as partners. So DTU are a project partner, and so is Isobel now at the European Space Agency. And so we have regular project meetings, and they'll continue after now. We may even carry out some more fieldwork in the future. We may have a reunion back down here in Rotherham in a year or so's time.
What's your experience of being on an Antarctic research station? Is this the first time for some of you?
Yes, it is.
Yes.
It's great. It's a totally different environment than the UK for sure. So I think it's
Yeah, it was my first time as well. I've had a great experience. Like, everyone is really helpful and friendly, and yeah, if you want to do something, you just go and ask, and most people are just ready to help. And as you said, like, we've had such good weather for 2 weeks, so we were expecting to have maybe like half of the days with not so good weather, but we had like really great weather, so we could go on the field like almost every day. We also saw like some orcas and penguins and seals. So yeah, it was a really nice 2 weeks.
But it also makes the logistics of the campaign easier to be on the station. Because normally we are working out of airports and you have to ask permission to go to the airplane to do all of these things. Here we're basically just involved in the full operation and come and download our data from the plane when we like to do it, not when everybody's available. When we do operations in Greenland, we will usually fly for 6-7 hours and then have to sit 1-2 hours in the plane downloading data afterwards. Here we can go back, get a cup of tea, and then go to the airplane and download data, which helps quite a lot when you do extensive campaigns and run for many hours. Of course, you need permissions to go to the plane, but
just
there are still some rules.
Yeah. But it helps out when you work as a community here on base and you have a common goal somehow to make it all work.
I think from the perspective of the station as well, it's been super inspiring to see work that everyone has been involved in and that has got such a relevant impact, and then for you guys to give a science talk and explain it all, and from the operations side.
Yeah, it's an interesting project to deal with on our side as well because of the complexities with the flying. I think it makes everyone on base feel like they're part of the bigger picture and they're sort of helping out with stuff. So
from my perspective, I feel certainly the land ice measurements that we've collected that are much higher quality than we would normally be able to achieve in Greenland, just because we have to work at such a frenetic pace in Greenland and we can't rest. We have to work for 3 days solid, and there isn't the base support to help out with things when things go wrong. In the field this time, we were drilling our equipment to reassemble it because it wasn't working properly, and there were tools on the plane that had been brought from the base by Hannah, who had the forethought to bring stuff out because things don't always work in the field. We don't have field assistants in Greenland, and so you have to do it all yourself. I'm certain our data is much better because we've had the time to think carefully about what we want to collect.
And how many cores have you got left to process now in your last day and a half, or maybe even 1 day?
1 day and a half left, and we just have 2 more boxes full of ice to analyze. But it's good, we did 6 out of 8, so just
2 left.
Yeah, and we've only lost 1 piece of core so far, so I think that's pretty good going.
How did you lose it?
Professor failed to take the photograph. That was
It's fine, it's just a photograph that's missing, but we already did all of the stratigraphy and the weighing. And it's just a photograph that sadly is missing. So.
Maybe
it's somewhere at the back of the old Jenny shed. If you want to go and search for it, it's 86 centimetres long and there's a pile of ice cores.
Yeah, because we don't keep them, so we just,
Oh, they just thaw out.
Yeah.
And then...
Yeah, so this afternoon we're digging snow in Scrub Out, and we've actually brought snow to the base. Actually, everybody else is clearing snow from the base, and we're bringing snow to the base.
So how much longer does the rest of the project go on once you guys are back home? Because there's a lot. There were other things to do with some ships, weren't there? And how long is the project set to last for?
Yeah, the project, I think there's another 3 years left on the project in total. And then the project is much broader in the sense that it has a large modelling component. So all of these new observations that we've been gathering will be fed into climate models, and that will help us better understand what's going on with Antarctic sea ice and to understand what will happen with Antarctic sea ice in future.
We hoped to use the new ship, the Sir David Attenborough, but it wasn't ready in time for the project, so that's why we used the Polarstern. But there's still an option to use the SDA at some stage in the future if it becomes available, so we'll keep our fingers crossed, because the measurements we're making on the ground are great. They give us some understanding of penetration into snow and ice, but it's not sea ice, and so we really do need to get some people out on sea ice in the deep ocean to get a new data set. And the only way you can do that is through ships.
Cool. Thanks, guys. Do you have anything else you want to ask? But thanks very much for your time. And it's been great having you here, and safe journey home.
Thank you.
Thank you.
Thank you.
As you've just heard, A lot of vital work is carried out in Antarctica over days, weeks, and for projects like Defiant, years. But contracts do vary in length. There are many roles available in the jobs section of the British Antarctic Survey's website, and you don't have to be a scientist to work at the bottom of the world. There are other roles such as engineering, administrative, catering roles, plus many others. So take a look if you're thinking of a new challenge. And if you enjoy listening to the Iceworld podcast and listening to me say this every time, please write a nice review for your favourite episode. In the next episode, we'll hear from British Antarctic Survey and University of Cambridge PhD student and ornithologist, that was a mouthful, Paul Whitelaw, who has worked at Rothera for 2 seasons, documenting the ecology and population structure of birds such as the South Polar skua and the blue-eyed shags. He's got some really interesting results to share with us. See you next time.